Well, Yellowstone is one of the country's most visited national parks, but social media rumors about the Yellowstone volcano on the verge of eruption are causing a lot of confusion online.
Deep beneath the surface of Yellowstone National Park, the Earth churns with a force so immense it defies comprehension. For decades, scientists have closely monitored the supervolcano that lies dormant, yet not dead, under this iconic American landscape. But now, that dormancy may be drawing to a close. Recent tremor swarms, unusual gas emissions, and unprecedented ground deformation have led volcanologists to issue what they are calling their final warning. Yellowstone may be on the brink of eruption. This is not a speculative fear or media exaggeration. It's a culmination of decades of research converging with real-time data that shows a system under pressure, straining against the crust that contains it. Before we start, smash the like and subscribe buttons for more updates. The Yellowstone caldera, often referred to as a supervolcano, is not like the typical stratovolcanoes that dominate landscapes such as Mount St. Helens or Mount Fuji. It is a massive underground reservoir of molten rock spanning nearly 50 miles in diameter, with its past eruptions leaving behind enormous calderas and altering global climates. The last major eruption, occurring roughly 640,000 years ago, reshaped the region entirely and hurled ash across North America. Since then, the magma chamber has quietly refilled, building pressure in ways that only the most sensitive instruments can detect. Now, those instruments are screaming a warning that few want to hear. One of the most troubling signs has been the frequency and intensity of earthquake swarms in the area. These swarms, clusters of small to moderate quakes that rattle the park in quick succession, are nature's pressure valve. But when they increase in number and depth variation, they often indicate that magma is moving. Over the past year, seismic activity has surged beyond historical norms, with hundreds of quakes recorded in single episodes. Each jolt is a reminder that the earth beneath Yellowstone is not still, not safe, and perhaps not far from a violent release. Compounding the concern is the unusual behavior of the ground itself. Satellite imagery and ground-based GPS sensors have recorded uplift patterns in the caldera's surface. Parts of Yellowstone are rising several centimeters per year, a rate that, while not catastrophic on its own, signals that magma is pushing upward with increasing strength. In some areas, ground deformation has taken on a bowl-like pattern, suggesting the chamber beneath is ballooning with heat and molten material. Geologists know from past eruptions elsewhere that such deformations often precede explosive volcanic activity. Alongside seismic shifts and ground swelling, the park's hydrothermal systems are behaving erratically. Geysers that were once predictably dormant have begun to erupt unpredictably, and some have stayed active far longer than expected. Steamboat Geyser, the tallest active geyser in the world, has entered a hyperactive phase, erupting with a frequency not observed in decades. These are not merely spectacles for tourists. They are signatures of change, signs that the subterranean plumbing of Yellowstone is undergoing pressure-induced transformation. Even more alarming is the spike in gas emissions across the park. Instruments have detected an uptick in carbon dioxide and sulfur dioxide venting from fumaroles and hot springs. These gases are direct byproducts of magma interacting with groundwater and surrounding rock. While Yellowstone always releases some volcanic gases, the recent increase is both statistically significant and contextually concerning. Elevated emissions of sulfur dioxide, in particular, are consistent with magma nearing the surface. When combined with deformation and seismic activity, this trifecta forms a pattern eerily similar to other volcanic systems that erupted in living memory, such as Mount Pinatubo in 1991 or Chile's Calbuco in 2015. The implications of an eruption at Yellowstone defy easy description. This is not a matter of regional concern. This is a planetary threat. A full-scale eruption would eject vast amounts of ash and aerosols into the stratosphere, potentially altering global temperatures for years. The ashfall would not be a localized event. It would sweep across the United States, potentially burying agricultural lands in the Midwest, clogging engines, collapsing roofs, and contaminating water supplies. Major metropolitan areas such as Denver, Salt Lake City, and even Chicago could experience disruptions that last months or longer. Air travel would grind to a halt across much of North America. Volcanic ash is not like ordinary dust. It is comprised of jagged particles of pulverized rock and glass that can destroy jet engines mid-flight. The aviation industry, already sensitive to natural disruptions, would face unprecedented logistical nightmares. Supply chains, already strained in the modern era, could buckle under the weight of limited transportation and disrupted energy grids. Beyond the ash, there is the issue of climate alteration. Supervolcanoes can inject tens of millions of tons of sulfur aerosols into the upper atmosphere. These particles reflect sunlight, leading to a phenomenon known as volcanic winter. Global temperatures could drop by several degrees, affecting crop yields across continents. This cooling might not last a few weeks or months, but years. The resulting food shortages, economic upheaval, and migratory crises could reshape societies in ways we've only seen hinted at in history books, chronicling the aftermath of ancient eruptions. But even if the eruption doesn't reach the cataclysmic scale of its predecessors, a moderate eruption would still be massively disruptive. Local ecosystems would be devastated. The iconic landscapes of Yellowstone, its wildlife, forests, and rivers could be transformed into ash-covered wastelands. Tens of thousands of people living in nearby towns like Jackson, Cody, and Bozeman would face immediate threats to life and property. Emergency services, no matter how well prepared, are not equipped to handle the simultaneous evacuation and care of tens or hundreds of thousands under such dire conditions. The economic fallout alone would reverberate globally. Yellowstone is a geological linchpin in a fragile equilibrium of nature and human infrastructure. Its eruption would likely trigger cascading effects on insurance markets, food prices, and energy distribution. Infrastructure across the western United States could suffer long-term damage, including highways, railways, and pipelines. The psychological toll of watching such a monumental force unfold, knowing it was long anticipated but ultimately uncontrollable, could erode public trust in science, government, and preparedness systems. Scientists have not issued their last warning lightly. Their pronouncements are not panicked outcries but data-driven conclusions born from years of methodical observation and peer-reviewed modeling. Yet even they acknowledge the limits of their predictive power. Volcanic systems are notoriously complex, and Yellowstone is among the most intricate. Still, the convergence of seismic, geodetic, hydrothermal, and gaseous indicators has painted a picture that is hard to ignore. They are seeing the signs that typically mark the transition from dormancy to awakening. Adding to the tension is the lack of precedent for a society as advanced and interconnected as ours confronting a supervolcanic eruption. The eruption of Tambora in 1815 led to the year without a summer, but that was a world without airplanes, internet, or global food supply chains. Yellowstone's awakening would test the resilience of modern civilization in ways we've never truly rehearsed. The emergency protocols exist on paper, but how they would function in the chaos of real-time disaster remains uncertain. Communication infrastructure would be among the first to falter. Ashfall interferes with radio and satellite signals, and emergency broadcasts could be cut off just when they're most needed. Power grids are highly vulnerable to both ash accumulation and cascading demand spikes, potentially plunging entire regions into darkness. Hospitals dependent on electricity for everything from ventilators to sterile environments would struggle to operate at capacity. In colder regions, a prolonged volcanic winter could stress heating systems and cause spikes in respiratory illnesses. The warning from scientists also raises urgent questions about public perception and response. Despite the ominous signs, many remain unaware of the severity of the threat. Yellowstone, for most people, is a vacation spot, a place of beauty and wonder. It's hard to reconcile that image with the reality of a ticking geological time bomb. Governments face a difficult balancing act, warning the public without inciting panic, preparing emergency responses without paralyzing economies. Yet time may not be on their side. Delays in preparation could prove disastrous if the volcano transitions from signs of unrest to active eruption within weeks or even days. Technology offers some tools, but not certainty. Supercomputers can simulate eruption models, and AI algorithms can analyze patterns in real-time data streams. But these systems are only as good as the inputs they receive. And while volcanology has advanced by leaps and bounds, it remains an inexact science, full of chaotic variables and incomplete datasets. Scientists can say with confidence that Yellowstone is more active now than at any time in recorded history. What they cannot say yet is precisely when the eruption will occur, or how massive it will be. That uncertainty leaves humanity with a sobering choice: prepare for the worst, or risk being caught in its wake. Preparation could mean investing in ash filtration systems for public buildings, stockpiling food reserves, and designing evacuation routes for communities in proximity to the park. It may involve more ambitious measures, such as geoengineering to deflect some of the effects of a stratospheric ash plume, or international agreements to share food resources in the event of agricultural collapse. These are not the kinds of decisions that governments typically make during peacetime, but the clock may soon force their hand. Yellowstone's rumblings are more than geological events. They are messages written in seismic waves, gas plumes, and shifting ground. Messages that speak of a system under pressure, a world about to change. The silence of millennia is breaking, not with a sudden explosion, but with a slow building roar beneath our feet. And though the world watches with a mix of awe and dread, the truth remains unmoved. Nature does not negotiate. It does not wait for convenience or consensus. It acts. The growing urgency surrounding Yellowstone's supervolcano is not just about its potential eruption, but also about what it reveals regarding humanity's relationship with the Earth itself. The planet has always been alive, constantly reshaping itself through the movement of tectonic plates, the growth and decay of mountains, and the unstoppable forces of volcanism. Yet Yellowstone is on another scale entirely, a reminder that beneath our cities, roads, and carefully constructed civilizations lies a force that can erase all of it in moments. The scientists who have been monitoring the caldera understand this better than anyone, which is why their warnings have now reached a tone of finality. For years they have studied every tremor, every rise in the ground, every change in the geysers, but now the system's escalating behavior suggests that the countdown may be nearing its end. What makes Yellowstone so dangerous is not just its size, but its nature as a supervolcano. Most volcanoes erupt through a single vent, releasing lava flows and ash plumes in relatively localized events. Yellowstone, however, is essentially an enormous cauldron of molten rock lying just below the surface. When it erupts, it does not merely produce lava, it releases vast volumes of pyroclastic material, ash, and gas with explosive force. The caldera itself, nearly 34 miles by 45 miles, is a scar from the last time this happened. And that scar is the result of an explosion so immense that it blanketed half of North America in ash. This is not conjecture. The evidence is preserved in layers of rock, soil, and sediment across the continent. The complexity of Yellowstone's magma chamber also sets it apart from other volcanic systems. Research has revealed that there are actually two distinct magma reservoirs beneath the park. One closer to the surface, composed largely of partially molten rock, and another much deeper and larger. The interaction between these two reservoirs creates a highly dynamic system, capable of shifting rapidly. When pressure builds in the lower chamber and transfers upward, it can lead to sudden and dramatic changes in the surface indicators that scientists measure. This layered structure makes prediction particularly challenging, as it's difficult to know which reservoir is currently dominating the activity. Adding to the danger is the sheer thermal energy present beneath Yellowstone. It is estimated that the heat output of the geothermal system is roughly equivalent to several dozen large nuclear power plants combined. This energy is constantly heating groundwater, creating the iconic hot springs and geysers that attract millions of tourists. Yet this same heat is also a byproduct of magma movement and pressure accumulation. The more heat and gas that are released at the surface, the more scientists worry about the shifting conditions below. Even as the scientific instruments around Yellowstone transmit their final alerts, the broader implications stretch far beyond the boundaries of geology and atmospheric science. This is not just a natural event, but an existential stress test for modern civilization. A scenario in which every link in the global chain, from politics and economics to mental health and human mobility, would be forced to react to an unstoppable force from below. This population movement wouldn't be confined to one region. Just as the ash from Yellowstone could travel across the globe via atmospheric currents, so too could waves of displaced people. Those living in heavily affected areas, parts of the United States, Canada, and even parts of Europe and Asia impacted by disrupted climates, might be forced to seek refuge elsewhere. Such migration pressures could overwhelm border systems, refugee infrastructure, and humanitarian organizations, leading to cascading challenges that defy conventional policy responses. The psychological toll of such a transformative event is also impossible to underestimate. Human beings are deeply tethered to patterns and predictability. A supervolcanic eruption that alters seasons, dims the sun, and changes landscapes overnight would cause an immense collective psychological rupture. The mental health crisis that could follow would not simply be about immediate trauma, but a slow-burning erosion of stability. Depression, anxiety, and existential dread could affect populations far beyond the blast zone, fueled by uncertainty and a loss of control over one's environment. Religious and cultural interpretations of the event could further complicate global reactions. Throughout history, significant natural disasters have often been interpreted as omens, divine punishments, or apocalyptic signs. In a world hyper-connected through social media and shaped by polarizing ideologies, the eruption could give rise to radical narratives and movements. Some might call for repentance, others for revolution. Conspiracy theories could spread like wildfire, muddying public understanding and undermining coordinated responses. Faith, fear, and misinformation would all collide in the information battleground of a post-eruption world. The eruption would also become a defining inflection point in the global scientific community. While some would celebrate the accuracy of predictions and the bravery of those who raised the alarm, others might critique perceived shortcomings or delayed actions. Funding for Earth sciences could surge as the world realizes how little is truly known about the planet's deepest systems. Young people might be drawn en masse to careers in geology, climatology, and emergency planning, not out of curiosity alone, but out of an urgent desire to better prepare for the next unavoidable confrontation with Earth's internal power. Economically, Yellowstone's awakening could trigger a seismic shift of a different kind. Markets, already susceptible to fear and volatility, would likely crash at the first confirmed eruption. Insurance claims from physical damage would be dwarfed by the economic ripple effects of prolonged trade interruptions, failed harvests, and suspended travel. The global economy, interconnected yet fragile, would be stretched to its limits. Sectors like tourism, aviation, and agriculture might collapse temporarily or restructure entirely. Meanwhile, industries like alternative energy, indoor farming, and data analytics could see unexpected booms as humanity looks for ways to adapt. Technology would simultaneously become both a crutch and a limitation. Satellites might track ash plumes and weather changes with precision, but those same satellites could also be rendered ineffective by electromagnetic interference or atmospheric scattering caused by ash and aerosol density. Communication platforms, vital for coordination and public awareness, would face overwhelming demand and possible outages. The digital divide, already a global issue, could become a matter of life and death, separating those who have access to critical updates from those who don't. Medical infrastructure would be challenged in ways that modern systems have never encountered. Respiratory conditions would spike, particularly among vulnerable populations like children, the elderly, and those with pre-existing conditions. Hospitals in affected zones might fill rapidly, struggling with dwindling power supplies. Emergency medical logistics, including the transport of critical supplies, would require unprecedented coordination at both national and international levels. Even education systems would face disruption. In the aftermath of a major eruption, school closures would likely extend far beyond the immediate region. Contingency plans for remote learning, improvised during the COVID-19 pandemic, might prove insufficient under a scenario in which power outages and damaged infrastructure become the norm. Students, educators, and institutions would have to reimagine learning in a world where physical presence, internet access, and clean air are no longer guaranteed. From a scientific perspective, Yellowstone's eruption would provide a once-in-a-millennium opportunity to study the inner workings of Earth in real time. Researchers could gather invaluable data on the behavior of magma, the spread of ash, and the long-term climatic effects of such a massive geological event. But this would come at a steep cost. Equipment could be lost, field stations buried, and researchers put at risk. Ethical questions might arise about continuing scientific exploration in devastated areas versus diverting all resources toward immediate human relief. The agricultural implications would be particularly grim. A volcanic winter could slash growing seasons, reduce sunlight, and decimate crop yields across multiple continents. Countries that rely heavily on imports, particularly in arid and equatorial zones, could face devastating food shortages. In wealthier nations, food prices would soar, rationing might become necessary, and black markets for staples like rice, wheat, and corn could emerge. Governments would have to make hard choices about food distribution, prioritize certain regions or demographics, and confront the moral weight of those decisions. Energy production, too, would face complications. Solar power systems could underperform for months or years due to decreased sunlight, while hydroelectric systems might suffer from changes in precipitation and snowmelt patterns. Coal and natural gas might see temporary resurgence, even as they contribute further to environmental instability. Nuclear plants, potentially operating in more extreme climate conditions, would need enhanced cooling and safety protocols. Meanwhile, public pressure for a resilient and green energy grid could accelerate the transition to more adaptable technologies, if the infrastructure survives long enough to support it. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Yellowstone's warning? Will it erupt soon or calm down? We want to hear from you. Thank you for watching and see you next time.